Okay, welcome everybody. We're going to go ahead and get started with today's Friday webinar from SEDAC and Illinois Energy Now. Today's topic is new construction going beyond code. And we have Sumi Han, who's the Director of New Construction here at SEDAC. Sumi, would you like to take it away?
Sure. Thank you, Andy. So thank you everyone for joining us on SEDAC webinar today. My name is Sumi Han. I am a Director of New Construction here at SEDAC. Today's topic is new construction going beyond code, and I'm planning to spend about half an hour to present this webinar. So if you have any questions during the webinar, please type in your questions in the chat box, and we will try to address those as they come or at the end. Illinois Energy Now is an energy efficiency program administered by Illinois Department of Commerce. Illinois Energy Now includes incentives and services for public sector energy efficiency projects and low-income housing improvement, and also the technical assistance and education program. SEDAC is supported by Illinois Energy Now program, and it is a partnership between University of Illinois at Urbana-Champaign and 360 Energy Group. So this webinar is for public sector, new construction projects, and major renovation projects in Illinois. And it is also for projects in early design phases, and projects in construction completion phases, and any other projects in between. And it is also for anyone involved in planning, design, and construction of new buildings and major renovation projects in Illinois. This webinar will cover how to achieve high performance design and how to take advantages of new construction incentives. And we will conclude with some case studies of new construction incentive projects done by SEDAC. So SEDAC can help you to achieve high performance design. You can apply for new construction design assistance service on SEDAC website. And also we can help you to receive some new construction incentives. You can apply for new construction incentive review at SEDAC website. So first, we are going to talk about a high performance design. So what will it take to achieve high performance? So here I listed 5 items, and we will go into each item in the next following slide. So here I will just list those. So first, set energy goals. And second, pick the right team. And third, focus on energy. And verify energy goals, and plan to maintain. So first, set energy goals. So as of January 1st, 2016, you must follow either IECC 2015 or ASHRAE 90.1 2013 if your project is in Illinois. But those are the a minimum requirement. Here, the vision for today's webinar is a beyond code energy efficient buildings. So to do that, you need to have 2 goals. One is design energy goal, and second is performance energy goal. So design energy goals. Here, I'm showing you some thing that pretty looking similar to what you just look at for the minimum requirement. But here what I'm showing you is actually the next version of code. For instance, IECC 2018. So this isn't published yet, but the draft is out. And then ASHRAE standard 90.1 2016. This is actually recently published. So you can actually look at the next code cycle for 90.1. And ASHRAE 189.1. This is called High Performance Standard, and current version is 2014. So these kind of things are the references for you to set your design energy goals for your project. And also LEED, it has an EA credit 1. So for instance, if your goal is to improve something like 12% beyond beyond baseline, you get 1 point. And if your goal is improve something like 48%, then you get 19 points under this credit. So this kind of, the point system that you can set as a goal, how many points you're going to get for your project, that could be your design energy goals. And last one is 2030 challenge. This is initiated by AIA Architects, and it is for, it is kind of ambitious goal, but it is for all new buildings and major renovations to be carbon neutral by year to 2030. So now we are going to talk about performance energy goals. So for this, we're going to look at the metric of EUI, energy use intensity. EUI is calculated by adding up all annual building energy use and divide that by building area, square footage. The graph on the left show you the wide range of EUI per different function or different building types. So on the left, I'm not sure if you can see my cursor, but the one on the left is supermarket and grocery store. And the EUI is, if we are looking at just the orange graph, because that's a national median data. And then if you look at this, it's around like a 500 EUI. And the next is hospital, and it's around like a 400 EUI. And it ranges until this one is unrefrigerated warehouse. This one EUI is something around like a 50 EUI. So what you can see is depending on what kind of building, the EUI really changes and it varies. And we're gonna just look at, for example, for office, the one in the middle here. So the graph on the right, it shows, yes, the national average is somewhere around 94 to 100 for the office, but there are examples that, even though it's same office building, there are buildings that use much less than the national average, from 14 to 30, 32, 40 EUI. And this one, the 14 EUI, happened to be in Switzerland, but the rest of these three are all in US, one in Colorado and Wisconsin and Maryland. So depending on your building type, you can see the national average. And also you can look at other good examples to set your performance energy goals for your high performance building. And the second point in the high performance building, pick the right team. So experience as well as commitment matters. So look for these qualities in your team members. The first one, the experience working within a fully integrated design process. Second, prior success. Third, the emphasis on energy modeling. And fourth, enthusiasm. And the last one, clear buy-in on team's energy goals. So everybody could be on the same page and everybody can work together to achieve those goals that you just set for the high performance building. And next, we're going to talk about focus on energy. The graph on the right, x-axis shows time. So on the left, it's early design stage, and then construction, and then operation. And then y-axis shows the savings potential or investment or cost in terms of dollar amount. So what it shows is the importance of the earliest possible point in the design process, because that's when you have a high saving potential with the least cost. So that is very important in the earliest possible point. And also, it is important to maintain that commitment throughout the process. Next, in the high performance design, the first step was setting the goals, and now it's time to verify your energy goals. And how do you verify your design energy goals? We say the energy modeling is a good tool. So we recommend to have a energy model in the early stage and also often. So not only one at the end, but actually, it evolves with the design process. So in the pre-design or early design, you use energy modeling as a benchmarking tool, and then later on, you use energy modeling as a concept modeling, and then design support. And when actually you have a construction document, you use energy modeling as an energy prediction of your high-performance design building. Then how do you verify performance energy goals? We talked about performance energy goal as like EUI. You can do it by, metering or sub-metering. And those are really important to actually measure how this building actually, perform. Also, you can use a tool such as Energy Star Portfolio Manager or Energy Dashboard. You can look at SEDAC newsletter. It covers energy dashboard. What it is a real-time energy consumption monitoring. So you can actually see how this building performs, and that's how you can verify your performance energy goals. And then last point in the high performance design is plan to maintain. So staff training is really important. We've seen many buildings that has very sophisticated building automation system, but once the knowledgeable maintenance person retired, rest of the staff have no idea how to use it, and that's not a good thing. And the building cannot perform as a high-performance building. So that's really important that have a continuous staff training. And also the user training, the occupant training is important. For instance, you have a very good daylight sensor and your fixtures are controlled by daylight sensor, but your occupant have the blinds always closed. That doesn't actually work. So these are really important to emphasize to achieve high performance design. So I would like to kind of wrap up this first section of high performance design to pointing out the SEDAC top 10 energy smart tips on new construction. You can go to this link, and we have many useful publications there, and this is a one. And it actually lists very practical items or strategies that you can follow to have high performance design. And for instance, here we listed as orientation and form, and we say orient your building on east-west axis instead of north-south axis, and minimize west glazing and shade south glazing. So you can just look through and see if any of these strategy works for your design. So now we're going to talk about the incentives. So if you go and click this link, this is a link to this 2016 and 2017 the new construction program guidelines and application. It is a 30-page or so document, and it includes many legal languages, and it shows you the requirement to apply for the incentive and have some information on incentive rates and also worksheet how to fill it out. But I highly recommend that you look through this application if your project is, interested in receiving new construction incentive. But contact us with question, because I understand this could be a little confusing or daunting. So do not hesitate to contact us once you have read this and have questions. We're very happy to assist you. So for the new construction incentives, in terms of timeline, in a simple way, I would like to say that if your project has a 100% construction document, it's ready to apply for the new construction incentives. And there are roughly two types of incentive in new construction incentive: prescriptive and custom. And actually, you can mix and match both prescriptive and custom. And actually, I have an example of this type of incentive later on in the case study. And then funding limits, there are some limits and funding, but I just want to point out a good news. There used to be a cap of $300,000 per project in terms of new construction incentive. That limit has temporarily lifted. So if your project has potential to save a lot of energy and receive more than $300,000, this is a good time to do that. So you can apply and hopefully get more than usual maximum amount. So as I said, there are some prescriptive, which is measure by measure, lighting, envelope, HVAC, or water heaters, and kitchen equipment, and custom. It requires some, so anything that doesn't fall under prescriptive, you can think of as a custom. But usually custom project, they have building energy model. But doesn't mean that you need to have building energy model to be qualified for the custom incentive. But the custom incentive, it's 8 cents per kilowatt hour saved and $2 per therm saved. And high performance design bonus. This is designed to encourage people to build a whole building energy model. So if you have a whole building energy model, then you can get custom incentive. And on top of that, you can get this high performance design bonus, which ranges from 40 cents to $1.40 per square foot. And now we're going to just look at some examples. These are like a screenshot of actual application. So under prescriptive incentive lighting, so if you have efficient lighting system and use less watt than what the code required, then for example, this project is a library. So according to ASHRAE 90.1 2013, the required LPD is 1.19 watt per square foot, and this particular project uses only 0.63 watt per square foot, and the area of this library is 64,000 square foot, and the way you can calculate the incentive is you subtract 0.63 from 1.19 and multiply that by the square footage of 64,000, and you get about $10,000 of incentive for the lighting measure. And the next example is the envelope. And here, this particular project has R35, and the required R value for zone 4 and 5 is R31.3, and the square footage of the roof was 85,000 square foot. So the way the incentive was calculated is that you subtract 31.3 from 35, and then you multiply that by 85,000, and then you multiply that by the incentive rate of 8 cents. Then you get somewhere around $25,000. And here I want to emphasize that when we say R here, R value, this one is a total effective assembly R value, meaning that it takes account whole assembly, not just the insulation. And for the prescriptive incentive under HVAC, there are different HVAC system, and then if your HVAC system or equipment is more efficient than what is listed here as a qualifying efficiency, then you get certain amount per capacity per each type. And then custom incentives, here the example. So if you have a whole building energy model, then you have a baseline energy model, which is code compliant, and you have a proposed energy model, which is your designed energy model. And hopefully this is always using less energy than the baseline. So for example, this project in the energy model, it says the baseline, the code compliance is they're using somewhere around 6 million kilowatt hour, and proposed using somewhere 4 million kilowatt hour, and then natural gas 130,000 therms for the baseline, and then 128,000 therm for the proposed. And that the way the custom incentive is calculated is that first you subtract the proposed from the baseline, and then you multiply that by the rate of 8 cents. And then you get something around $174,000. And the natural gas, you do the same thing and get something around $4,000. So this particular project got somewhere around $178,000 for the custom incentive. And because this project has a whole building energy model, they also qualify for the high performance design bonus. And high performance design bonus varies on which baseline you use, and also how much of energy cost you saved beyond code. And now we're going to talk about case study. This is an example of a rec center at a park district. And this particular rec center used lots of LEDs. So they have a lighting power density of 0.82 watt per square foot. And they have very efficient envelope system. They have precast concrete. So insulation is sandwiched in between the precast concrete. And they also have a ground source heat pump and very efficient domestic hot water. So they got a total incentive of $77,000, and they use a prescriptive incentive. The second example is a high school. So this particular high school have a 0.89 watt per square foot as a lighting power density. And this one is an example that they use a prescriptive and custom. So they got lighting and envelope as a prescriptive incentive, but for the heat pipes and heat wheels that they have to preheat the outside air, that was not required by the code, but they did it and saved some energy. So they provided us the calculation done by the manufacturer of the air handling unit, and SEDAC reviewed it and thought it is reasonable. So we recommended the custom incentive for that. So total of $110,000 is awarded to this high school. And then elementary school. This elementary school has a 0.66 watt per square foot of lighting power density, and they have very efficient windows, and also they have geothermal HVAC system. This particular project, they use a prescriptive, meaning they didn't have energy model, and they got $61,000 of incentives. And I think this is our last example. It is a university teaching laboratory, and they have a LEDs and T8s, and they have a lighting power density of 0.70, and they have a heat recovery chillers. And they didn't claim any gas savings, but they claimed lots of electric savings. And because the sheer size of this building, they got lots of high performance bonus, because those are calculated by per square foot. So in total, $266,000 was awarded to this project, which includes custom and 30% beyond code energy, 30% beyond code high performance bonus. So that is the end of this webinar, and I don't see any questions came in. So probably we will end here. So thank you everyone for joining us today. We look forward to working with you on your new construction and major renovation projects. Hold on, I think there's... Are there any examples of a whole building retrofits, so not completely new construction? Well, usually the major renovations, usually it's addition And I don't recall particularly if there's any like a whole building major renovations. I don't recall, but it is definitely qualify for the new construction incentives. So if your project is the whole building retrofit, then and also your project is almost done, meaning that if you have 100% construction document, contact us and we will help you fill out the application to receive the incentives. So any other questions? I guess not. So then we'll look forward working with you in the future. So call us with questions, and also we will send you an email asking for the feedback of this webinar. So if you can fill out the short survey, that'll be really great. And I guess it will then conclude today's webinar. Thank you, everyone.